Radiologist time and money.
Okay, thanks a lot for the introduction. My name is Georg Langs, I'm with contextflow, and we are developing deep learning-based software in order to find, or that helps finding similar cases to the cases that you are looking at right now. And I'd like to start with giving you a bit of a background about what's the motivation, what's the idea behind doing search and behind kind of investigating methods to compare cases across individuals. And so one of the insights that we are making in precision medicine and in kind of more advanced studies of diseases is that many of the diseases that we are dealing with and that we kind of lumped into one category turn out to be actually collections of many different diseases that each of them might have very different optimal treatment strategies and treatments. And so I think the challenge that we can tackle with machine learning and that we can tackle with technology is help individuals kind of navigate this landscape of disease phenotypes and patient phenotypes and find similar patients, because that might be the basis, or that might be the best and only basis in order to decide for the specific personalized treatment that is optimal for one patient. So I think we are kind of observing a shift in our view of diseases from very big categories to a very fine-grained landscape of individual diseases that have to be kind of matched across individuals in order to learn something about the mechanics of these diseases, but also in order to treat each individual better. So I think all of you know that the community of medical image analysis, of segmentation, of detection, of characterization of image features has made very big strides, and I think that leads to a status right now where we are able to get quantitative features out of imaging data. And with the data that we are observing in the clinic, which consists of this imaging data together with reports, with patient histories, with a lot of information that we have about individual patients, we have kind of the necessary basis to provide individual clinicians with the evidence they need to make good decisions. And we at contextflow believe that one key is to be able to compare patients, to find patients that are similar to the patient you're looking at in terms that really matches similar diseases, similar kind of kinds of diseases, similar of necessary and optimal treatments. And so the core idea of the algorithms that we are working with is translating images into features. And that's a big machine learning problem, because we want to optimize the features in a way that they reflect relevant disease characteristics, and then use deep learning in order to first of all find these features and then compare these features and then speed up this entire comparison process so that while you're reading a CT image or MR, you are able to kind of draw very quickly cases that are similar to the case that are in front of you. And so the specific things that the software does is, first of all, I think once you're able to have a case in front of you and see comparable cases, see comparable patterns, you can kind of identify what are the possible findings, what are the possible diagnoses for this patient, what are the possible and optimal treatments for these patients. So you can use it to confirm what you already guess. You can use it to kind of establish a first guess of the best diagnosis. It can also provide you evidence, so it's more than just a computer-aided diagnosis system, because it shows you what are the cases based on which these finding suggestions and these therapy suggestions are made on. And the third one that we kind of learned more and more during kind of observing and talking to the radiologists that are using this system is that many of them would like to have a very quick way to get information about, well, that's something to look for differential diagnosis, this is some literature links, all the things that you do right now, but that costs you a lot of time because you have to dig into literature, that you have to kind of make a few guesses about what might be in front of you and let that be the guidance in looking up literature. And so I think once you have the ability to perform search, you can use it in order to provide evidence for a decision, but you can also provide additional information in a very quick way. And so in the last couple of minutes of the presentation, I'd like to kind of guide you through the prototype or through the software, actually how it's right now, and then show you a few new features that we've developed over the last year. So this is kind of our interface right now that enables you to navigate very, very large databases based on the case that is in front of you. So the basic idea is that you are looking at the CT image, you have a region that you would like to know more about, you just mark it and the rest is fully automatic. So based on these regions, we look into the database, we find similar cases that carry similar patterns. Since this is an existing patient database, we already know the findings, we already know the diagnosis, so we can tell you what this cohort has in common, which might be pretty good suggestions about the state and the kind of characteristics of your patient. You can dig deeper into this database, again, very, very quickly. You can look at individual patients, look at the distribution of these patterns and compare them to your patients. And you can look into literature, and we already put you at the right place in the literature. So you don't have to search around, but based on the pattern that you have in the patient in front of you, we guide you to the right place. So it's totally interactive. After you have this first guess, you can explore this information. And so in the last 2 minutes, I'd like to show you 2 new features that we thought are even more helpful because they make the entire experience even more quick and also provide you immediately with the right information. So the first one is anomaly detection. So we can parse databases and the cases of the day and look for things and regions and objects and findings that are out of the ordinary. So we can provide basically a very quick parse of the entire volume that is in front of you and guide you to the positions in the volume that are out of the ordinary, that are worth a second look. So you don't have to scroll through everything, but we guide you to the right place and provide you with the necessary information. And in practice, this looks like this, so that we show you a heat map of where this volume contains strange or possibly diseased region and start the search from that. The second novelty is that we go even one more step further and try to save you more time. We call it Smart Worklist for now, and that is before you even open a case, we can search through all the cases in your worklist and figure out which of them do contain abnormalities and link them to the priority of these cases. So that means that we can transfer the worklist that you're usually working with, that you're kind of working through the cases, into a bit of a smarter configuration where you already mark the cases that contain abnormalities. We can give you a guess about what it might be, so that you can kind of order the workload, that you can kind of distribute the workload among experts and thereby kind of speed up the entire process. So what we do overall is we provide a clinician, a radiologist, with the possibility to get the evidence, get suggestions, get relevant information that you need while you're reading a case. All of the development that we are doing is to do that very accurately, to get the most relevant information in front of you, and to do it very fast. And if you want to have a look at the demo and at the actual prototype, just over here at the corner, we would be happy to show you a bit more. Thanks.
Thank you very much, George. Are there any questions from the audience? Yes.
You say that you have around 70,000 data in your database. You have around 70,000 data.
Yes.
You try to do the analysis live. And how long do you do that? And if you are in a clinic where it's not there, do they have a special hardware for that, or do they do that on the cloud?
Yeah. So basically, the database that you're searching through, that is pre-calculated. So we kind of have an ingestion phase where you kind of upload the data or do it on-site. But the preferred model is to be on the cloud, because many of the institutions that we are working with are actually very happy to kind of share and pool the data, because each of them has a slightly different specialization and they would like to search in data of other institutions. So the core idea is to have it, the core way we do it right now is to have it in the cloud. And the actual processing that has to happen live is just for the cases that are happening during the day, and that's possible. How long? So the search takes about 1 or 2 seconds.
Any further questions? And thank you very much again. So next presentation is for the company.